Hi, this is Edmund, and this is my video on gradient descent. And so, first of all, in order to understand what gradient descent is, you have to understand what a gradient is. So as you can see here, this is a best representation that I found of what a gradient is, which is based on color. So the definition of gradient is where you have an increase or decrease in the magnitude of a property that is observed in passing from one point to another. So in this image, you can see that you have this light pink color going onto this darker blue color. And so as I move from one point to another, the magnitude of the color is changing. Therefore, this is a representation of a gradient. And so machine learning applies this concept with this algorithm called gradient descent. So understanding past knowledge of linear regression and the least squares method, you can then create the gradient descent algorithm. How it works is that first, remember that your goal is to find the line of best fit, which is one that minimizes the error calculated by the least squares method, which you can see represented here. Next, based on that, you can generate a line y equals mx plus b. However, based on your y-intercept and your slope m, you can find essentially how much error that line will have using your least squares method. And your optimal line of best fit will be the minimum point on this 3D curve, because it is minimizing error. And so, in order to find this, you need to have an understanding of derivatives. Now, why are derivatives important? Well, that is because at your minimum value, that is where your derivative is 0, because your tangent line will have a slope of 0. Therefore, say this would be a local minimum here at this point, then you would be able to draw a tangent line there, then the slope would be 0. So, using this knowledge, you know that if I have a derivative value that is positive, say like here, then I know that my local minimum is to the left. Vice versa, if my derivative value is negative, say like this, then I know my local minimum is to the right. So, using this knowledge, you can essentially create an iterative algorithm, which is essentially what gradient descent is. You basically repeat the process of taking the derivative and using that information to determine where you should take your derivative next, and go in which direction based on the number you get with the explanation I just gave. So, how does it work? First, I'll take a derivative, say here. Then, using a learning rate, I then take a step in one direction based on the learning rate. So if I set an arbitrary learning rate value of, say, I don't know, like 0.6, then maybe it'll jump over to here now. Now, there's two main ways to do learning rates. First, you either set a constant value or you have it decrease based on each iteration. And so the advantage of doing it the second way is that you prevent overshooting. Because if I just set a constant value that's too large, then what will likely happen is that I will take a step that is so large that I'll end up overshooting my minimum, and I'll never actually be able to approach it efficiently. Vice versa, if I do it the method of slowly decreasing the learning rate based on the iteration, then I can slowly approach it by step by step by step. And so, using the knowledge of linear regression, least squares method, this is how you get the algorithm of gradient descent, which is really useful when it comes to machine learning algorithms, which is why it's really important to have a solid understanding of it. And so, if you have any questions, you can feel free to leave a comment or talk to me in person.